Welcome, welcome, and welcome again to a new DJ Wilson STEM video. All right, so this is for my engineering students. We want to get into some space and some flight technologies. So obviously we're going to start building some rockets. However, here's a new skill. We want to introduce some new skills. Um, for this particular unit. One of those is going to start using some simulation software to be able to determine what our projects are going to do. So we're going to use some CAD. Again, CAD stands for Computer Aided Drafting and Design. And so again, this is another one of those resume things. So once we get to the end of the semester, we want to put this on our resume as far as some skills that we've acquired. All right. So let's do this. All right, so inside Schoology, so when you log into Schoology, excuse me, you're going to see this. Obviously, this is your homepage for my class, right? I've already posted the rocket engineering design process here. And for those of you that did what you were supposed to do, you already have a foundational knowledge of the engineering design process, especially if you were in my class last year. We are picking up on that. I am not reteaching that. So if you don't remember it, you need to make sure that you go watch the videos. And again, just if you didn't do what you were supposed to do over the last couple of days, it is in the 7th grade review materials. It's in this folder right here, engineering design process. There's 2 videos that I want you to watch. The one is a review of the engineering design process, and the second is how to complete the engineering design process worksheet. All right. And this is the engineering design process worksheet. Excuse me. All right. So I want to click on this. And here is the document that you're going to want to go into to complete your work. All right. So here's a problem. All right. You need to build a rocket that launches straight up and goes the highest and stays in the air the longest using a simple parachute recovery system. All right. Based upon the vocab, you should already remember kind of like what the recovery system is. It's a parachute. Okay. All right. So on this, I'm not asking you to do step 2 or 2A, but you're going to pick up at part 3. You're going to start creating some solutions. All right. So with the software that we're going to use, the simulation software that we're going to use, is this software right here called Open Rocket. It's on your desktop. You shouldn't have to do anything with it. So let's go into this software. All right. So let's do this. With our software, right, the first thing that we're going to do, and again, this software is a really great software to use to design our rockets, and this is what we're going to do over the next couple of days. So each day, you should be working on a rocket design, because again, remember the engineering design process, you need three potential rocket designs. And then what you're going to do is you're going to select one of those designs to build. Okay? So let's do this. Here's our nose cone. The first thing we want to add is our nose cone. Okay? So when we click on this, it's going to ask us some information about our nose cone. And we're going to use some stock parts. So these are parts that I'm just going to give you. But they are certain sizes. So the things that we have to do is we have to include the size and the material that these are made out of so that we can get the most accurate data. Okay? So right here it says shape parameter, and hopefully you guys' screens are clear. You're going to leave that where it is. All right, nose cone length. The nose cone length, is going to be 2 inches. However, pay attention here. Right now, this is in metric. This is in centimeters. So we need to change this. We need to click on this box right here and change it to inches. Okay? And so since the nose cone length is 2 inches, we need to change this to 2. Oops, that didn't do that right. And then the base diameter is going to be 1 inch. So we have to do that same process, change this to inches, and then change this to 1 inch. All right, our component material, when we click here, obviously that will change. When we click here, our nose cone is actually made out of a plastic. So what we're going to use is this fiberglass material here. Let me just make sure that, yeah, we're using that fiberglass material. And then once you do that, we're just going to click close. Okay, that's our nose cone. And then after we do that, then we're going to add the body of our rocket. Okay. Now, again, the material is going to be, the diameter is going to be 1 inch. Okay. So, but the length of our body is going to be 11 inches. So right here where it says body tube length, got to change this to inches and then make this 11. These things have to be, okay? There's no if, no ands, no buts about it, right? The nose cone has to be 2 inches long, 1 inch in diameter, and the body tube length must be 11 inches long and that same 1 inch diameter. Okay. Now we're going to change our component material, and we're going to use paper. Okay. And then close. All right, so there's a few things that our simulation is telling us right now. One is telling us about the stability of our rocket. It's telling us about the center of gravity, and it's giving us actually this red dot and this blue dot. These are the center of gravities, but the center of gravities for two different things. Okay, so this is the center of gravity lengthwise. And this is the center of gravity if the rocket was standing straight up, okay? Now, one of the things that's really important that you want the center of gravity for your rocket when it's standing up to be straight down the middle, because if the center of gravity is either to the left or to the right, then then your rocket, once it launches, it's going to veer either to the left or to the right, based upon your center of gravity. Now, this center of gravity, all right, your horizontal center of gravity, you want this to be along this, somewhere near the leading edge or of your main wing, okay? And the reason being is, if your center of gravity is near the leading edge of your main wing, then the majority of the airflow is going to be going around your fins, and it's your fins that allow your rocket to stay stable and to launch straight up. Because one of the things that you don't want your rocket to launch either to the left or to the right, because if it does, then it's taken away from potential height. Okay, so you want that. Make sure that you try to align that center of gravity near the leading edge of your main wings. But also, that helps with the stability. If your center of gravity is too far in front of your main wings, then it's possible that this is called cocking, that your shuttle will launch, and then because the center of gravity is not where it is, the fins will be out of order, out of alignment, and your rocket might flip. Okay, you don't want those things to happen. All right, for successful launch, you kind of want your horizontal center of gravity to be near the front of your main wing. All right, so let's do this. Let's add some different things that you're going to need to do for your rocket. So if you click here on the body, okay, there's a few things that we need to add. The first thing that we need to add is your shock cord. And obviously from our vocabulary, you should know what the shock cord is. The shock cord should be around 18 inches. So let's change this to inches. And let's change this to 18. Okay? And then just leave the elastic round cord, just leave that. Okay? And then close it. And then we have to add our recovery system. So let's click on the body again. And now let's add our parachute. So we're going to leave our parachute at 30 centimeters. Let's just leave it there. Okay. The material that we're going to use, this is not a rip top nylon that we're going to use. We are using a mylar type material. Okay. All right. And so then let's just make sure that, we're going to use the mylar. Yeah, we're going to use the mylar. Okay. And then we're going to close that. So we've added our nose cone, our body, our shock cord, and our recovery system. Okay. So now once we add all these, you'll see different things change within your stability, as well as when your center of gravity. Okay. So let's do this. We're going to add our engines first before we add our fins. Before we add our fins. Okay. So let's add our engine. Okay. And our motor mount is going to be our body tube. And then we're going to add a new configuration. Then once we do a new configuration, you'll see down here highlight, and then we're going to select a motor to use. We're going to limit this to A motors because we're only using an A motor. Okay. And the motor that I want you to use is going to be this motor right here. It says Estes A8. Okay. So here's your motor. Now, once you add that motor, you'll see some different things change. You'll see your stability change. You'll see now we have some information about our rocket and how it's going to fly, or how it may fly. Okay. All right. So right now it's saying our apogee is 31.1 meters. Okay. So you know a meter is about 3 feet. So it's saying right now our apogee of this rocket, if there's no wind and everything flies perfectly straight up, this rocket will probably get to about 90 feet. Okay. The max speed of this rocket is going to be about 29.4 meters per second. Okay. So it's going to reach that 90 feet in a little bit more than a second. Okay. So again, these things are really fast. Our max acceleration is 137 meters per second. Now let's do this. Right now, our rocket is extremely unstable. Now you might be saying, Mr. Wilson, Mr. DJ Will, how is our rocket unstable? Well, our rocket is unstable because there's no fins. Fins are what help your rocket fly straight. Actually for our class, rockets must have fins. You are not permitted to design or launch any rockets without fins. It's just not going to work, and it's not safe. Okay? So here's what we're going to do. Let's go back, and you'll see back up here these tabs. You'll see the rocket design tabs. Okay, we're going to click on this. Now we're going to add some fins. But the first thing that we have to do is you need to add a launch lug. The launch lug is 3 inches long, so the length is going to be 3 inches. So obviously you change the unit of measurement to 3. Well, to inches, then type in 3. And then the outer diameter is going to be in inches, but it's going to be 0.25 inches. And then close. All right, so that's your launch lug. Remember what the purpose of your launch lug is, to hold your rocket onto the launch pad, and so that the rocket will launch straight up. All right. So now, again, we added some things. So once we added the launch lug, so you'll see your apogee changed a little bit because we added some mass, we added some weight. But now let's start adding some fins. You'll see there's 3 different types of fins here. There's trapezoidal, elliptical, and freeform. Okay? Trapezoidal are just that. There's typically 4 sides. Elliptical, the rounded edges. And freeform, you can almost create your own type of wing. You can play around with this. All right, so let's go with trapezoidal. Actually, for your project, you're going to need to create 1 rocket with each fin design. Okay, as far as your design, and then you're going to make a determination of one of those 3 that you're going to build. So let's look at trapezoidal first. So we want to click on this one, and you'll notice that it automatically puts the fins where we want them. Okay? All right. Now again, if you want, you can adjust your fins. But before I do any adjustments, before I do anything, I want to take a look at what happened with my data. Take a look at where my center of gravity is now. Okay? Right? My center of gravity, my center of gravity moved. Okay? So my center of gravity is now here. My horizontal center of gravity is now here, which is really close to the leading edge of my fins. So that might prove to be a pretty stable rocket here. Okay? But I may even want to consider moving them up just a tad. But again, before I do that, let's look at our stability, right? But then also let's look at our apogee. Take a look at this. This is interesting, right? We added some fins. Now our apogee shows that our rocket is now at 37 meters. So, which is almost 6 meters higher than no fins. So that's almost 18 or 20 feet higher than if we had it with no fins. And so here is where we can start to play around with our design a little bit, okay? So you can look at fin cant. So remember, fin cant is the slant of the wings along the main body. I would encourage you, now again, it's your design. It's your design. I would encourage you to leave the cant at 0, okay? Because if you use the cant, it's going to cause your rocket to spiral. And that wasted energy, it may stay straight. However, it's not going to go as high. So to show you this, let's adjust our cant a little bit. So I'm going to change my cant by a couple degrees. Okay? So you'll notice my velocity slows down. My apogee really doesn't slow down that much, which is interesting. Okay. So I'm going to leave, but me personally, I'm going to leave the can't alone. Let's put that back at 0. Okay. Your root chord. Remember, your root chord is the length of the fin where it touches the body. So if I wanted to, I could try to increase my root chord length. Now notice what happens as I'm adjusting this. You'll see my apogee gets lower. However, my stability looks like it might get a little bit better. Okay? Because again, remember, the greater the surface area of your fins, the more stable the more potential your rocket has of being stable. Okay? And launching straight and not flipping or turning or cocking or veering off to the left or to the right. Okay? Now you could also adjust your tip chord. Remember, the tip chord is the length of the wing or length of the fins away from the body. So let's do this. Let's see if I'm going to shorten those. Okay? Now notice my apogee's gone higher again. These aren't really pretty fins, but let's do this. Let's use these and sweep the fins back a little bit and see what happens. Oh, now I got the 39 meters. So this is some of the things that you can do to play around with your design. Okay? One of the things that I will ask you to do is kind of leave, you can, again, it's your design, you can adjust the height of your fins if you choose to. But if you leave them at 3 centimeters, it makes it a little bit easier for us when we build it. Actually, let me phrase it. It's going to make it a little bit easier for you when you build your final rocket design. Okay? Now, your component material, just leave this at cardboard. Okay? Everything else, just leave. Now, once you have your design that you think that you're going to go with, just click on close. Welcome back. So, actually, I want to show you how to save your work. Obviously, you'll know that my rocket looks something different because when I was trying to show y'all some different things of the rocket, my software crashed. So make sure you save your work often, okay? So here's how I'm going to save this. Up here, you'll see File, click on File, and then Save As. You want to save this to your desktop. That's probably going to be either save it to your documents. That's probably going to be the best way, easiest way to save this. And so since this is my first potential solution, I'm going to name this Solution 1. And then press Save. All right. Now, if I wanted to open this back, if tomorrow, if you don't finish this today, right, tomorrow when you come back in the class, you open up the Open Rocket software, and then you click on File, and then Open, and then you'll see Solution 1. You can double click on that, and that will allow you to pick up where you left off. All right. So you'll see right now my rocket's apogee is 45.7 meters. That's simulated, right? So that's about 135, 140 feet in the air. Okay. I will share with you that anything above maybe 35 meters is going to be pretty good. If you get above 50 meters, there's some type of kink in the software because the engines that we're using, the average height of them is going to be about 100 feet, 120 feet. Okay, so you might be able to get 150 feet out of it. Okay, so let's do this. Let's go back to motors and configuration. So we did everything that we needed in motors and configuration, right? We set up the A83, right? and it gave us the information. But now let's look at the simulations. So here's that final tab. And so now what we're going to do is when we click on that flight simulations tab, and you're going to scroll right here where it says new simulation. So let's click on that. For new simulations, leave everything the way that it is, okay? The reason why I say this is this is a real software, and this software can be used to calculate wind speed, how well the rocket might do, and if too much wind is blowing, or if not, or anything like that, it will give you data. But what I want y'all to do is leave this the way that it is. And I want you to come down here and click simulate and plot. So when you click on this, it's going to just, again, same thing, leave all of this just the way that it is. And then let's click on plot. So this is going to give us some very important data here. So this is time across the bottom. This is going to give us the altitude in meters, right? And then this is going to give us the acceleration, the vertical acceleration. There's a few things here that are kind of important to see as well. So here you'll see apogee. Okay. Remember, apogee is the highest point of the rocket away from the surface of the Earth. So right now, this rocket's apogee at about 45 meters, it will achieve that apogee around a little bit before 3.5 seconds. Okay. Ideally, this blue line right here, which tells you the recovery system ejection, okay? Which, remember, once your rocket launches, there's going to be a second charge that blows out your recovery system. So your rocket's going to launch, it's going to get to its apogee about 3 to 5 seconds or so, and then that ejection charge is going to blow out your rocket. And that's going to push out the recovery system. Hopefully your parachute opens up, and then your rocket will float back down to the Earth. Okay? So here's some things that this is telling us. That the apogee, and then within about a second or so, our ejection charge is going to blow out. Ideally, you would want your ejection charge to blow out of the top after your apogee, maybe a half second to a second. The closer these two lines are together, the better the possibility of your rocket staying in the air the longest. Okay, longer. So right now, this is saying, my picture's in the way. This is saying that my rocket should stay in the air about 14.25 seconds or so. Okay, which is pretty good. For many of you who may have done some previous research on this assignment, know that in many of my classes, the average time is more than 14 seconds. Well, no, it ranges. It ranges. We've had students who hit the 40 and 50 second time limit, and we've had some that 4 or 5 seconds because of some rocket flaw or they didn't follow the instructions when we were creating them. All right. So, but again, let's get back to this apogee and recovery. Okay. So typically between a half second and the second, you want this recovery charge to blow out. Now, how do we change this? Okay. Let's close this out and I'll show you how we change it. All right. And the only thing that we can really do in our design is alter the shape and size of our fins. Okay, so one of the things let's double click on the fins. Oops, yeah. And one of the things that we can do is let's right here where it says position relative to bottom of parent component. Let's try and move our fins forward a little bit, closer to that center of gravity. So you'll see that as I move my fins closer, it's not really having too much of an effect on my apogee. At least it doesn't look like it, right? But let's see if it's having an effect on my stability. I don't think it is. Oh, actually, it is making a difference with my stability. Because again, remember, the closer your leading edge is to the center of gravity here, the better your stability is going to go. So here's some things that you can do. Again, the higher this stability number, you don't really want that. You want to get that stability as close to 1 as possible. So it looks like something like this might give you really good, pretty good stability, but look at what it does to your apogee here, right? That's not really good. So let's move that back. Okay. And then one of the things that you can do is, again, you can play with these numbers as much as you want. So here's what I'm going to do. I'm going to adjust this sweep back a little bit more, right? Look, 47 meters apogee, okay? And stability 1.8, right? However, one of the things I'm going to do is I'm going to adjust that tip chord a little bit more. I'm going to make it more of a delta wing. Oh, look, 53.7 meters apogee, right? However, look at my stability. That's not good, right? And remember what I showed you in the presentation about the shape of the fins, right? This is great for speed, but because you're losing that surface area here at the tip, you're losing stability, or you're losing some potential stability here, okay? So let's run our simulation with this and see what happens. So let's close this out and let's run a new simulation. Keep everything the same, simulate and plot. Keep all this the same. And now look what happens, right? So now, right, we have this massive, right, 150 something feet up, right? 150 something meters. We have this 50 meters right here, where let's see, 55 meters apogee point, okay? That ejection charge, that's really, really close together. That's really good, right? However, let's look at some of the negatives, right? Well, not necessarily negatives, but you have that 17-second mark here, right? So those are some things that, as you're designing your rocket, you want to make sure that you're thinking about, okay? So once you get the design that you want, we're going to go back to rocket design. Once you get the design that you want, you're going to click on the print screen button. The print screen button is at the top right of your computer, of your keyboard, that is. You'll see it says print screen, okay? So press that. And what that does is that, in a sense, takes a screen print of your screen, okay? Then what you're going to do is you're going to go back to your engineering design process. Since this is solution 1, I'm going to paste that right here. So here's my design. Here's my first design, solution 1. Then, just like we've always done before, I'm going to explain in detail how this solves the problem. Okay, this particular wing style, this is a delta wing style, right? It solves the problem because it provides a lot of speed, right? And the rocket can go the highest and stay in the air the longest using a simple recovery system. That's how it's going to solve the problem. There's benefits, obviously, the design, the apogee. And again, I want y'all to use the data from Open Rocket. You have to use the data from Open Rocket, as well as your knowledge of the fin styles. Now, your cons. What are negatives of this design? Well, the negatives of this design is I need to be precise in cutting my fins. 2, because they're delta fins, right? They're going to be really fast, but they're going to decrease the stability of the rocket. Okay? So, remember, 3 pros, 2 cons. And then once you put this in here, then start working on your second solution. All right? So let's go back to Open Rocket. I'm going to save this. Right? And then I'm going to make a new design. Okay? So, to make a new design, the easiest way to make a new design, everybody, the easiest way, I'm going to take my fins and I'm going to press the delete button and get rid of my fins. Because remember, everything else stays the same. The nose cone, the recovery system. But when you save this, I'm going to save this. I'm going to click on File, Save As. I'm going to save this one as Solution 2. Okay? So now watch this. If I were to go to my Open, now right here you'll see there's Solution 1 and Solution 2. So if I wanted to go back to Solution 1, I'm going to click on Solution 1 and make sure that this says Open and not Save. So there's my Solution 1. Okay? And then if I want to go to Solution 2, Open, Solution 2. And here, again, just click on the body, and then now I have to use those elliptical wings. So again, I want you to, each solution has to be one of these designs. So 1 trapezoidal, 1 elliptical, and 1 freeform. All right. I really look forward to seeing your designs, and hopefully we'll get these things. We'll start building, and then once we start building, we'll find some warm days, nice days to launch these. All right. Thanks for watching, and do great and have fun.